At local noon, you can check your latitude. That's the cosmological reality of how far up and down you are. So I've got a globe right in front of me. The North from the 60s, the North Star, so you got um here's the North Star. Don't mind that. That's whatever. But North Star's right here. And so it stays in place. The North Star stays in place. Or maybe it goes the other way. North, and so this distance times 5, and then another times that, you get this, um, it looks kind of like a bird, I guess. Depend on this angle, but whatever. And then this could be, yeah. Um, and so at night, just like the sun at noon, at night, you use the Polaris North Star to find your latitude, how far up and down you are, how north you are. The equator, the North Star will barely touch the horizon on the equator. Also on the equator, it'll be 12 hours of day and night year round. But in the Arctic, it'll be very dark in the winter and very bright in the summer, like the midnight sun, etc. You know what I mean? This globe is from the 60s. So the sun will always be to the south, except for maybe the rarest of sometimes, like at in the like, yeah, it'll set in the west and rise in the east, but it'll be on a southern arc. So that's why if you can see the sun, especially in the midday, if it's nighttime, south is going to be to the east of the sunset, and in the morning, south is going to be to the west of the sunrise. But it is always to the south. So is the moon. The moon goes on that same path, and the planets, they go on that same path. And again, it's like it's and it takes about 24 hours. And the planets look to be about the same size as the stars, just like the moon looks to be the same size somewhat as the sun, but they are closer and smaller, like when there's an eclipse. So if you are looking on the same pathway that the sun and moon goes on, for the most part, yeah, and you see stars that are really look like the planets that even like Pluto, when it is visible, and it takes a long time, but it'll just look like a pin dot. You can see it with your bare eyes. If you stare at the Saturn long enough, you'll see the rings, and you'll see how far away it is, and you'll see Jupiter as being really big and a little bit closer than Saturn. You'll see Mars as being somewhat red and close and small. You'll see Venus as being even, smaller and yellower. Mercury is pretty freaking whatever. It's Mercury. It's real close to the sun, so it's kind of sometimes blotted out. But you can see all that. So this here could be Polaris, or that could be the sun at noon, and that's where I am, more or less. The horizon is plane, and straight up is 90 degrees. And so the sun at local noon, or the North Star at any time, the North Star will not move. Everything orbits around the North Star. So knowing 90 degrees is straight up, and across is plane. You just look at it. You look somewhere between straight up and the horizon, and you get 45. And so then you find the North Star, if it's the same latitude anywhere on the planet as me, just go a little bit more, and that's how to find your latitude. If you need it really precise, there's tools for that. But you can do that. You can do that. If you make alligator choppers, never seen an alligator, but or a hippo, or like a bird, like if you make a chicken beak out of your arms, you can if you make a chicken beak, like one arm is straight up and one arm is straight across, and then you bring your cross arm, you leave one arm straight up, and you bring your horizon arm, your horizon arm, just until you get to the North Star, or if you know it's, and so, um, this technique is for a chart, but you use it too if you don't have a tool or a chart, um you go as close as you can without going over or under that line. Like, and using a phone with one hand, you should use, but basically it's like you find that threshold, so it does not go, and that's like just like the Earth is round. It kind of, or your eyes are round and Earth is round. So it's right here. You know what I mean? So you do that with you can do that with, if you're looking at the, so at local noon with the sun at local noon is right, yes, the threshold. And once it's done with being local noon, it'll start to set. You know? Does that make any sense? So it's like the sun's rising, it's noon, and it starts to set again. You know what I mean? So that technique has different. It's just finding the arch of the utmost arch of a circle. And it starts to set. That's local noon, and you can do that too with the North Star, and probably you can do that with the horizon. Scan the horizon, and that when, yeah, it's not inaccurate. And so, in other words, when the sun is at its highest most peak, that is your latitude and local noon. When the sun is at its highest peak before it starts to taper south, I mean west, all that, yeah. It'll, and then, yeah. I hope that makes sense.